Okay, so I've got a magical video for you guys today. This is a guide to setting TVB and BIOS. Why are we setting TVB? Because, as you can see over here, somehow TVB actually reduces voltage at idle, which I just don't understand how that even works, because that's literally like not even close to what TVB is apparently claimed to do. So I just by this point have no idea what's going on. But um, yeah, we'll just go with it. So anyway, TVB right now, as you can see, is enabled because my idle voltages are now all of a sudden quite a bit lower. I'm gonna be honest, I have no idea how this affects AC load line undervolting, because the fact that these voltages are lower now, I don't know if it changes the voltage behavior at load or what exactly happens, but yeah, again, we're just gonna go with it, so I don't know. Anyway, don't set voltage limits, guys. I also, again, don't know why this happens, but apparently, not apparently, I've watched it happen. When you have a voltage limit, even when it's not like super like low, like my voltage limit was 1.35 on my chip, and I decided to go install RivaTuner again because I usually don't use it, but decided to go just check it out because I was like, well, what are the odds? I mean, my chip has a 5.5 target, like way lower than 1.35, but I was like, ah, screw it, let's just see what happens. Like, let's see if it actually is downclocking, because I'm just curious. Because I hadn't checked before, because I thought obviously logically they wouldn't do that, but apparently logic uh, doesn't really apply. So yeah, apparently my chip is doing 5.4 with a 1.35 volt limit. So yeah, guys, no voltage limits. Can't do that. 1.4 wouldn't make sense because that's like I could just run water then. Like I don't know, like literally. So no voltage limits, guys. I mean, unless you want to compromise gaming performance. I mean, if you want to do that, that's fine. But like, um, voltage limits will cause your chip to throttle down in games, so that's kind of the thing. TVB apparently helps idle temps and like voltages. I have no idea why this happens. Like, I honestly can't explain this, but whatever. So how do we like tune TVB to not like have the annoying you know the annoying boosting that causes weird problems. So basically, guys, this entire process right here, I've typed it out beforehand because I don't want to annoy you guys by typing it during the video. Um, you can go ahead and pause the video if you want and read through it. I can read through it, but I don't think there's much point. What it boils down to is this: every motherboard vendor has different looking menus. I don't know why it's not standardized. Like Asus looks different than ASRock and MSI and Gigabyte. They all look different. So I can't tell you how to do yours because I just don't have every single platform, and I can't like do that. But yeah, the process is pretty straightforward. You find TVB, enable TVB, and then once you can find the option that actually has your TVB settings, what you want to do is you want to go find the 1 and 2 core ratio boosts, which are they should be listed there, and you should see something regarding a temperature A and a temperature B, and basically temperature B should always be higher than A. But it'll tell you that, like it'll show you the temperature. I'm not sure if your board will say temp A and B. Mine does, but yeah. So temp A for me is it will always be lower than temp B, and then um, the idea being the temp A is the one that hits first, and then temp B is the one it calculates the next value off of. So for my board, for example, when I set temp A to 1x, which is what I put my example here, this is how I have mine configured, by the way. So for temp A, I have 1x and it's at 0 degrees Celsius. And what that means is that it'll run 5.8 gigahertz on 2 cores until it hits 0 degrees Celsius, which is obviously always because that's like sub-ambient. So once it hits 0, it drops to 5.7 as the max boost on the 2 cores. And then once it's 20 degrees, it drops it by a further 2x to 5.5. So that's how mine is configured. I'm not exactly sure how it look in your BIOS, but if you can um, understand the principle, then it should be pretty easy to apply. the thought process. And yeah, then what you'll have is, I mean, you can choose different values as well. So I mean, if you want to choose like 20 for temp A or whatever, it's up to you. Whichever temperature you feel like is in your mind is safe enough to run the chip at its higher two core boost at. But yeah, I have mine at 0 and 20 because I don't really want to see those boosts ever. So yeah, that's me. But yeah, temperature B, guys, the resulting value after it hits temp B and does its final step down. So for example, mine is 2x, like I said, to get the 5.5 for my chip, which is the 3900K. If you have a 4900K, I think the 4900K, look, again, you're going to have to look in your own BIOS menu, and because I don't own all these chips, so I don't know what your values look like, but it'll tell you what your max ratio boost is, and what you want to do is find a way to get your chip down to what it's supposed to be running at, so it doesn't do like two core boosts above the all core boost, because there's no point. So for 4900K, hypothetically, I think it should be 5.9. I don't know. It might be like 6. It might be 5.8. I don't know, but whatever it is, um, again, idea would be you want to get down to 5.7 if you have a 4900K. If you have a KS, again, you have to check your own values and apply it to your own setup, because again, I just haven't owned all these chips. I just like I can't even find the values because people online don't have the stock values because they're all overclocked, so it's like impossible to find them. And Intel sites values are not the same as what the chip actually runs at. So I mean, like, that's useless too. So yeah, I really can't give you KS values because I just have no idea where to find them. Again, Intel's website does not give the correct values because the values you actually see in real world use and in uh, different board vendors' BIOSes, that's not the same as what Intel has on their site. So yeah, that's kind of that. And okay, also regarding undervolting, again, I just don't know what the LLC MO values are for your boards. So if you want to do the whole AC/DC equalize thing, that's something you're gonna have to research your own because I can't give you the values. Um, but for undervolting, I'll just add a small section because it doesn't take a long time to explain. So for undervolting, idea would be, so step one, let's say undervolting. Let's go. So the reason why you have to disable SEP is because when you mess with ACLL, it's going to cause current excursion protection, and then you're going to have the diminished scores and stuff. You can undervolt via the VRM voltage. I don't bother because on certain boards it just breaks everything. I don't know why. Like on some motherboards, setting the VRM voltage when you're trying to run the automatic VF curve on the CPU, it like just breaks things. I don't know why. Like Asus works fine. I don't know if Gigabyte works fine because I just haven't used Gigabyte that like often on Intel. And I think MSI doesn't really work the way you want it to, and on my platform, ASRock, it completely breaks LLC, so I don't know, like it's screwed up. But yeah, so I don't bother with the voltage on the VRM. I just leave the VRM voltage auto, and yeah, IA SEP disabled. All you're gonna do is this. So you're gonna find ACLL, and you're gonna bring it down. So to run ACLL at 0.01 in every single application, every single game, actually requires a really good sample. Like I'm talking like a SP110 3900K and the 4900K even higher, because the 4900K you're targeting 5.7. So to get a chip that can run 0.01 ACLL, you actually need a freaking strong 4900K. And if you have a KS, same thing. If you want to run 0.01 ACLL, you actually are going to require like a really strong CPU to not crash in certain loads, because you will just crash in certain things. Like you will just straight up crash in shader compilation, you'll crash in CS, you'll crash in COD, you'll crash in whatever. Like 0.01 ACLR is actually freaking hard to run, unless you have a very strong chip sample, because it literally it brings that load voltage down tremendously. So it's good to get it low. It's gonna help you, but yeah, you need a strong sample. So ACLL really, if you can get down to 0.01, you don't have to worry about anything else. Like if you can get this down to 0.01, it's actually rock solid. There's really no reason to worry about further dropping the voltage. Um, so yeah, but otherwise, what I will say is step 3 is a bonus step. Bonus. You can sync ACLL to DCLL and LLC. And how to do that, guys? DCLL needs to match LLC, always. And you need to know what the different VRM LLC values correlate to. Should you do this? I honestly don't know. It's up to you. I don't do it. I'm not gonna try. I mean, I can't because my board doesn't have. For me to match this to like my ACLL, it's like I can't do it. Like there's no way of doing it because just like there's no setting for that. I don't have a VRM LLC accessible with the stock. I don't know. I can't explain it to you guys, but for me, I can't do it, and it doesn't affect me at all. I don't really care to do it because I don't see any real point to it. It doesn't change anything for me personally. But if you want to have it like the way Intel likes it, which is ACLL equals DCLL, then and your VRM LLC, then you can do that. But yeah, it's a bit difficult to get that set up. Asus motherboards have it. Asus boards have synchronize, where it actually syncs up all the values for you, and then you just set the VRM LLC, and then it sets ACLL and DCLL like correctly by itself. That's Asus boards. So yeah, I don't think Gigabyte, well, I know Gigabyte and MSI don't do it that way, and neither does ASRock, and neither does EVGA. So yeah, but personally, guys, I think bringing down ACLL is fine. It'll get you the effect you want. So that's all that really matters at the end of the day. Regarding like the VRM voltages and everything else, like don't worry about it. Just ACLL really is the only thing you have to worry about bringing down, and you'll see that bringing down ACLL does actually drop your voltages, your temps. It won't drop power draw because you're always going to hit the normal like power limits anyway, so that wouldn't matter. But it'll bring down your voltages and your temps, and yeah, because ACLL is like, I mean, it's hard to explain, but it's like a extra voltage that your VRM basically supplies to the vid request. But yeah, I believe 0.01 ACLL is what the CPU's like VF curve is calculated off on Asus boards. I believe that's how it works. But anyway, so yeah, ACLL 0.01 is the target, but it's hard to run. I'm currently experimenting with 0.1 because I don't know, I just feel like trying it out and seeing if I can get it working. But yeah, I had some problems running 0.1, not 0.01, but 0.1. It's been working fine in COD for me, just like recently. So I think I'm gonna keep trying to daily 0.1. I think CS:GO might have been having problems because of just like the game itself or whatever. I don't know, but yeah, try and bring your value down. Like I said, don't worry about VRM voltage. Don't worry about offsets. Don't worry about that stuff and don't worry about. And I honestly don't think you have to worry about the board LLC and stuff because, like I said, setting certain values on certain motherboards is gonna break the process of how the board like sets the voltage regulation. Because on mine it does. So, and I've observed it doing weird stuff on MSI as well. So I just don't feel like it's worth the headache. And some commenters that I've talked to as well in my like videos that have brought down the ACLL values actually have had good success bringing down their temps and stuff, like their temps and their load voltages. So yeah, bringing down ACLL, guys, that's the target, that's the goal. Disable SEP. You don't need SEP. You don't really need SEP, guys. You don't need SEP if you're going to bring down your load voltages with ACLL tuning and you're going to disable SEP. You have the power limits in place, and if you have TVB in place, it's going to do this magical thing that it does to bring down. I don't know how this works. Like, it doesn't make sense. Like, why does this work? I don't even understand. Like, this is what TVB does. Like, what does TVB do? What does TVB do? Intel. Let's see. Let's see what TVB does. Okay, here we go. We have Intel. Here we go. From straight from the horse's mouth, as they would say. Let's see. I'm not going to read this, by the way. I'm going to just like scroll through it, and we can just read it together because we all know how to read. I don't care. Here we go. Increases clock frequency above. Below. Like, how does this correlate to dropping down my idle voltage? I don't understand. Like, but the thing is, like, this that it says it does, like, this claim, this whole thing, like, people say that their chips, they're all core changes. I've never seen that happen. Like, to my knowledge, it's just okay. Here we go. Here's an example. 3900K. Cool, fine, cool. I have this chip, so it's good. Okay. Man, isn't it gonna show us the That's so stupid. That's so useless. Anyway, diagnostic tool, lol. Arc driver, lol. Don't never get this, guys. Never ever use XTU, please. Never ever ever under any circumstance use XTU. There's like just 0 point. Like how like I don't know how like saving yourself like a minute to get to BIOS is gonna justify using XTU. Like that to me is just crazy. Anyway, so yeah, let's go to specs on the 3900K. Alright, so yeah, apparently my chip has an all-core 5.4, which is not true. It has a Turbo Boost Max 3.0 or 5.7, which I don't even know when this occurs because I've never seen it 5.7 under any circumstance ever. Like, not even with 1 or 2 cores. I've just never seen this number ever. I don't know. And then 5.8 boost, obviously, which is the 2-core boost that just seems to happen for no reason. But yeah, so TVB apparently does that, which I've never seen it happen. Besides 2-core boosts, well, I don't know why it brings down idle voltages. I don't know why. Like, because it shouldn't. I mean, there's no reason for it to. So yeah, but anyway, try it out, see how it goes, and yeah, guys, just make sure to get your temp A and B limits in place. Make sure your stuff isn't boosting to a ridiculous, stupidly high 2-core. And just to show you guys it actually works, I'm going to open up testbem 5. Okay, my testbem 5 is freaking. So we'll let that run for a little bit, just so you guys can see my chip is now running its all-core mode. It's now observed that we're running a semi-heavy load that's loading all the cores. You can see the equals downclocking. P cores are running at 5.5. And then if I stop the load, once it goes back to its automatic boosting behavior, this is usually where you'll see the 2-core boosts pop up all of a sudden. They'll just kind of appear. And we'll wait for it, but obviously they're not going to come because I've got it configured correctly. So yeah, because the temp isn't low enough. If the temps were low enough, so let's say we were at let's say my chip was at 20 degrees or below 20 degrees rather, so like 15C, it would be running at 2 core boost would be 5.7. And if I was at, let's say, negative 5 degrees, I would be at 5.8. But obviously, my chip will never achieve those temps. So, yeah, no more 2 core boost for me. So, yeah, guys, that's how you do it. And I hope this helps, I guess. And yeah, cheers, guys.